This is a recording made 17 years before playback existed. It is not a groove, it is a line, drawn in soot, on paper, by a bristle that trembled while somebody sang. The man who made it never heard it. He never intended to. And for the next 148 years, no one else heard it either. It sat in a French archive, a picture of a voice, with no way in. Paris, 1853, Edouard-Leon Scott de Martinville is 36 years old, and he is not a scientist. He is a printer and a bookseller. He sets type. He proofreads other men's books for a living. And he has spent years of his own life on one obsession: shorthand. The problem of writing speech down fast enough to keep up with it. He has already published a history of stenography, so he knows the failure intimately. Every system ever invented still loses words. People talk faster than anyone can write. Then, while proofreading engravings for a physics textbook, he turns a page and finds a diagram of the human ear. He stops, because the ear does not lose words. The ear catches everything. And looking at that drawing, the taut membrane, the tiny chain of bones, Scott sees a machine. Photography had just learned to fix light onto a plate. So why could nothing fix sound onto a page? He starts building a copy of the ear out of workshop parts. A barrel for the canal, a stretched membrane where the eardrum goes, a run of levers standing in for the bones, and at the end, instead of a nerve, a bristle held against a surface, waiting to be moved. But here is the part almost everyone gets wrong. Scott was not trying to invent playback. Playback was not the goal. It was not even a thought. He coated the surface in lampblack, the fine black soot off an oil lamp, and let the bristle scratch a clean line through it. The line rose and fell exactly as the air had. He called the result a phonautograph, sound, writing itself. And what he believed, what he would defend for the rest of his life, is that people would learn to read it, that a trained eye would one day look at those waves and hear words, the same way your eye is turning these shapes into a voice right now. On the 26th of January, 1857, he seals his design in an envelope and deposits it with the Academy in Paris. 2 months later, he is granted a patent. He builds better machines with an instrument maker named Rudolf Koenig. Brass, glass, a hand crank. And he starts recording anything he can put in front of the horn. A cornet running a scale, a voice counting, fragments of speech that come out as unintelligible smears. He is assembling a library of sounds that no one, including him, can hear. And then, on the 9th of April, 1860, he does something a little different. He puts his mouth to the horn and he sings. A French folk song, the kind of thing everyone in Paris knew by heart. Au clair de la lune, by the light of the moon. The bristle shakes, the crank turns, and a clean line appears through the soot, about 20 seconds long, carrying a melody that nobody will hear for a century and a half. He labels the sheet. He files it away. It is, at that moment, one of the most extraordinary objects on earth, and it looks like a scribble. The reading never comes. Scott tries. He publishes examples. He coaches people. He insists it is only a matter of practice. And no one, not one person, ever learns to look at a phonautograph and hear it. The eye will not do what he needs it to do. What happens instead is quieter. And for him, it is worse. The scientific world takes his machine and keeps it. Researchers use the phonautograph for decades to study vowels. to measure the shapes of speech. His invention becomes a laboratory instrument, useful, unglamorous, and his actual dream is set down and left there. He never makes money from any of it. He goes back to the bookshop at 9 Rue Vivienne, selling prints and photographs to people who have never heard of him. 17 years after the song, in 1877, a man in New Jersey wraps tinfoil around a cylinder, shouts a nursery rhyme into a horn, and cranks it back the other way, and the horn answers him. But Thomas Edison did not know Scott's work. He was solving a different problem, and he solved it completely. Sound in, sound out, in one motion. The world named the machine the phonograph, and it named Edison the man who captured the human voice. In Paris, a 60-year-old bookseller read about it in the papers. In 1878, Scott wrote a pamphlet. He called it The Problem of Speech Writing Itself. In it, he laid out the dates, the sealed envelope, the patent, the recordings, and argued to anyone who would listen that the first recordings of the human voice were his and had been for 20 years. Almost no one read it. On the 26th of April, 1879, one day after his 62nd birthday, Edouard-Leon Scott de Martinville died in Paris. By every measure available to him, he had been wrong. His machine could not play. His pages could not be read. The man who recorded the first human voice never heard a recording in his life. The papers outlived him, bound into volumes, deposited with the Academy and with the Patent Office. They sat in Paris for 130 years, catalogued, occasionally photographed, still completely silent. Then, in 2008, a small group of American audio historians, engineers, and archivists who called themselves First Sounds went looking for them. They knew exactly what those sheets were, the oldest recordings of the human voice in existence. But they also knew the problem. A phonautogram is not a groove. There is no channel for a needle to sit in. It is soot and ink on flat paper. You cannot play a drawing. But there is another way to read a line. At the Berkeley National Laboratory in California, physicists had built a system for exactly this kind of problem. It is called IRENE, and it plays nothing at all. It looks. A beam of light travels along the paper at enormous resolution and measures where the line goes. Every rise, every fall, in order. Then the computer does what the bristle did, only backwards. It treats that drawing as the motion of the air that made it, builds a stylus that exists only as arithmetic, and runs it down a curve scratched into soot by a man in 1860. And in March of 2008, in a room in Berkeley, the file finished processing. And somebody pressed play. What came out was 10 seconds long. A woman, or possibly a child, singing Au clair de la lune at an ordinary pace. It went around the world in a day. But then the researchers found their own mistake. Scott had recorded a reference tone alongside the song, a known frequency, so that the speed could always be checked. They had misread it. Everything had been running at double. Corrected, the recording is 20 seconds, not 10. And it is not a woman, and it is not a child. It is a man, singing very slowly and very carefully into a horn, the way you sing when you are trying to make a machine work. Almost certainly Scott himself. So the first recorded voice in human history belongs, in all likelihood, to the man who invented recording. Alone with his machine, singing a lullaby to an instrument that could not answer him. He was wrong about nearly everything he was certain of. He was wrong that the ear could be beaten. He was wrong that the eye would learn to read. But he was right about the one thing that mattered. He said a sound could be written down and then read back, and it could. It simply was not a person who read it. It was a beam of light, 148 years later, tracing a line he drew in soot. Some signals get sent long before anything exists that can answer them. Scott sang into a machine that could not answer. 148 years later, it did.